Hello friends, how do you do? This is Yogesh Popat and today again we are here with a very interesting topic that you observe in your daily life, which is very much related to your activities, daily activities, and the topic is force. You can see the different interesting demonstrations I have kept here to justify each and every line what I'm going to say today, and we will have an interesting demonstration. I have a balloon here, I have a Hooke's law apparatus with a spring, I have this horizontal surface with a trolley, I have this inclined plane also, I have this ball to show you how the force acts. Okay, so one by one we will discuss each and every point, and with every topic I will indicate you the demonstration part. So first of all, what is force? Here it is written, it is a kind of push or pull, which is very much true also. Force is a kind of push or pull. But in my opinion, I would like to elaborate force in 4 different points. First, the force is something which changes the shape of the body. If you take this green ball, and if I am going to press it, you can see here, if I am going to press it, the shape of this ball will definitely change. So until and unless you apply certain amount of force, the shape of the body will not change. So force is something which changes the shape of the body. This is the first point. Force is something which changes the shape of the body. Now, to demonstrate the second part, force is something which causes the motion of a body. Suppose if I take this trolley here, and if I pull it with a thread, I am applying certain amount of force with the help of my hand, I am going to pull it. So you can see here, by applying a force, I am just causing the motion of a body. Again you can see here, this is a trolley and I am going to apply this force. One pan is also connected here, I can just apply some weights on this pan also which will apply some force, but I am just simply applying with the help of hand. So if I apply this force like this force applied by my force sets the body in a motion. Okay, so force is something which causes the motion of a body. Suppose if I take this blue ball and if I drop it, if I release it freely, so due to gravitational force it will go down, and the motion on this ball will be caused by the gravitational force. See, so the gravitational force is pulling this ball and responsible for causing the motion of a body. So force is something which causes the motion of a body. If you have to walk also, if you have to run also, you have to apply certain amount of force towards the earth, towards the ground, then only you will be able to move forward. Okay, so force is something which changes the shape of the body. Force is something which causes the motion in a body. Now suppose you have to stop this ball. Suppose if I am rolling this ball on this surface, I am going to roll this ball on this surface. I will just keep this little area empty. Okay, so if I roll this ball over this surface, after moving certain distance it will get stopped. It will get stopped. Okay, after rolling certain amount of distance, if I apply this force with the help of my hand to oppose the motion of a body, then it will get stopped. And if I don't apply this force also, after traveling a certain distance, this ball will get stopped due to frictional force of the surface. So force is responsible for causing the motion of a body, as well as force is responsible for stopping, for seizing the motion of a body. So force is responsible for changing the shape, force is responsible for causing the motion in a body, force is responsible for stopping the body, seizing the motion of a body, and last, force is responsible for causing the change in direction of motion of a body. If you're traveling in a straight line in your car or you're riding a bike, whenever a sharp turn comes, you have to apply a certain amount of force to direct your car or to direct your bike to overcome or to travel on that turn. So without application of force, you won't be able to change the direction of motion of a body. I have this pendulum bob here. If you see, if I roll it again slowly, what I am doing, I am just changing the direction of the motion of a bob by applying certain amount of force. What I am doing, I am applying the force at this point of a bob, and this bob is moving in approximately uniform circular motion. So in uniform circular motion, if you see in the last chapter also we have discussed, key in uniform circular motion, the direction of motion or the direction of velocity continuously changes. If I stop applying force, this bob will comes at rest. So without application of force, the direction of motion of a body will not change. I am just applying a force on this bob, and you can see this bob is moving in a uniform circular motion on a circular path. At circular path, if you draw a tangent at any point, that tangent will give the direction of motion of a body, direction of velocity of a body at that particular point. And if I stop applying force, this pendulum bob will comes at rest. Okay, so all these four statements I have justified with the help of a small demonstration. Changes the shape of a body, causes the motion in a body, stops the motion of a body, and causes the changing direction of motion of a body. You must have seen cricket matches. After putting the force with the help of a bat, the direction of ball changes. Okay, so this is what force is. Force is a push or pull, and these four properties are also applicable for force. Now we'll come to the discussion of different types of forces. What are the different types of forces? In this category, we have to discuss here two types of forces, two category of forces: balanced and unbalanced force, and contact and non-contact force. Now if we talk about, I will just remove these demonstrations from here, and one by one I will keep it here. So in this category of forces, I'd like to start with the category of contact and non-contact forces. If you see the non-contact forces, I have written three basic examples: gravitational force, electrostatic force, and magnetic force. If you see this gravitational force, if you take this object, if you take this ball, and is there any physical contact between this ball and the surface? No. So whenever there will be no physical contact between the two bodies, the body on which the force is exerting and the body which is applying the force, then that category of force will be termed as non-contact force. If I drop this ball, there is no physical contact between this ball and the surface. If I drop this ball, it will automatically go downward. Okay. Again, you can see it will automatically go downward. There is no contact between the surface and this ball. So gravitational force is an example of non-contact force. Okay. If you take the magnetic force is also an example of non-contact force. I have certain pins here, and what am I going to do? I will just show you. I will take some certain iron filings also. These are some iron filings. I am going to spread these iron filings here. And if you see, the magnetic force is also a kind of non-contact force. There is no physical contact between this iron filings and the pins, and this is a U-shaped magnet. But if you see, if I keep this very much closer to this without any physical contact, this attracts the pins and the iron filings, which shows that this is the magnetic force is also a kind of non-contact force. You have seen, you have observed that without any physical contact, this U-shaped magnet has attracted the pins and the iron filings. If you want to see it again I can show you that this is an example of non-contact force. These are the three few pins I have kept here, and you can see here See, without any contact, these pins are attracted towards the magnet. So magnetic force is also a kind of non-contact force. This balloon I have kept here, and what I am going to do, I am going to charge this PVC pipe by rubbing it with a cloth. When I rub this with a cloth, this pipe will get charged, and I am very much hopeful that this pipe will attract this balloon. Balloon is going to be little steady in state, and I am going to charge this to show that electrostatic force is also a kind of non-contact force. Now this cloth is also charged and this pipe is also charged. If you see this balloon will get attracted or maybe get repelled towards this. You can see the moment. Yes, you can see this moment. You can see this moment. There is no physical contact. There is no physical contact between the pipe and the ball, but still there is a moment in the ball. You can see this. Yes. Yes. You can see the moment. Okay, so there is no contact between this charged PVC pipe and the balloon, but still there is a moment in the balloon due to this charged pipe. The balloon is uncharged and this pipe was charged. So due to the charges, the electrostatic force at the interaction takes place between the two charged bodies, or one charged or one uncharged body. That means electrostatic force is also a kind of non-contact force. So I have shown you these three demonstrations: gravitational force, electrostatic force and magnetic force. These three are in the category of non-contact forces. Whenever there will be no physical contact between the two bodies, then that category of force will be termed as non-contact forces. Okay. Now in the category of contact forces. Now what is contact force? Contact force is whenever there will be a physical contact between the two bodies interacting with each other, then that kind of force will be termed as contact force. Suppose if I am keeping this block on this surface, and what I am going to do, I am going to pull this block on this surface. So whenever the two surface comes in contact during motion, there acts a frictional force. Frictional force is an opposing force which causes the opposition to the motion of a body. If you see here, I have drawn this diagram. If this is a table and if this block is kept over here, and if the direction of applied force in that direction, if I reverse the direction of force just to explain you, suppose this is the block which is kept over here, and if I apply the direction of force to be this side, I am pulling this block in this side. So this is the applied force applied by my hand, and the frictional force will act in that direction. The motion is in this direction and the frictional force will act in that direction. So frictional force is indicated by F here, and this Fa is the applied force. So whenever the two bodies or the two surfaces comes in contact with each other, there acts a frictional force. So frictional force is a kind of contact force. Restoring force, if you see, I will just show you the restoring force. What is restoring force? You can see here in the diagram. If you take a spring and if you stretch it with the help of application of applied force Fa, there exists a opposite force which automatically developed in the spring in the opposite direction, and this force is called restoring force. The restoring force is the force which tends to regain the original configuration of a body. Suppose if I show you a ball which I have shown you already, suppose if I take this ball and if I compress it, then the restoring force will be developed opposite to the direction of this force, and as soon as I release this force, this body will regain its original configuration. Okay, so what is restoring force? Restoring force acts on any of the body. It doesn't matter that it is a spring or any of the body. Restoring force acts on any body, any surface, whether it is a soft surface or a hard surface, but the restoring force acts on every body. In some cases, if you take this wooden surface, if I apply the force, there is no change in the dimension of this block, but there is a change which is not observable with the help of naked eye. The intermolecular distance will definitely change. Okay, so as soon as I remove this force, this surface also regain its original configuration. If you take this spring, I will show you one demonstration with the help of spring also. If I take this spring here, I have this block, this Hooke's law apparatus also, which consists of one spring. Okay, so this is the spring. If I keep this weight here, this spring will automatically get stretched. The elongation is in this direction. This is the direction of elongation of a spring. So the restoring force will automatically develop in the opposite direction. As soon as I remove these weights, it automatically gets up. So some force is responsible for regaining the original configuration, and that force is called restoring force. In case of compression also it will take place. If you compress the body, again the restoring force develops in the opposite direction. Okay, I have this spring also. With the help of this spring also we can understand the restoring force. I will just keep this to be here, and I am going to attach this spring here. This will take just 2 minutes time. If you are able to see this spring, I have just stretched this spring here, and if I release it, it automatically goes back to the original configuration. This is the direction of applied force. I am stretching in this direction, so the restoring force will develop in the opposite direction. As soon as I release it, it will automatically restore the original configuration. So this is the restoring force, which is also a kind of contact force. Next is the normal reaction. If you see the normal reaction is the force which acts on a body in a perpendicular direction. Suppose this is the block which I am keeping here. When this block is kept over the surface, the weight of this block will act vertically downward, which is shown by the blue arrow in the diagram. You can see here this W is equals to mg. To balance this weight, one force acts perpendicularly up by the surface, and that surface force is called normal reaction. If you take this block and if I take this marker here, this marker indicates the force applied by this surface in the upward direction, and this force is called normal reaction. Okay, so normal reaction is also a kind of contact force. As soon as the body comes in contact with any of the surface, the normal reaction automatically acts on that surface, and this force is called normal reaction. Okay, so this is all about the contact and non-contact forces. Every 6 examples I have shown you with the help of practical demonstration. If you see the second category, balanced and unbalanced force, this is also very simple. Suppose this is body A, and you are applying the same amount of force in both the directions. You are stretching this body with the same amount of force, same magnitude of force, but in opposite direction. So if you stretch any body with equal amount of force, equal magnitude of force, but in opposite direction, the state of body is not going to change. If you calculate the net force, the directions are opposite, so one force you have to take it negative. So 5 plus of minus 5, this minus 5 indicates any of the forces in opposite direction you have to take. So 5 minus 5, it will be 0 Newton. So if you can see here, the magnitude of net force is 0. That means the state of the body is not going to change. This is the example of balanced force. But if you increase any one of the force, one force is kept here, 7 Newton acting away from me, 5 Newton towards me. So there exists a 2 Newton net force. due to which the body B will move in that direction, 7 Newton direction, with the amount of 2 Newton force. Greater force minus smaller force. So this is the 2 Newton force towards right. This arrow indicates the direction of net force, which is towards right. So this is an example of unbalanced force. I have shown only 2 forces, many more forces are possible. Suppose if this is the direction of force also, 5 Newton and again 5 Newton. So on all 4 directions 5 Newton forces are applied. So again these forces will cancel out each other because they are equal and opposite. Equal in magnitude, opposite in direction. So this is again a kind of balanced force. Until and unless the unbalanced force acts on a body, the state of a body is not going to change. This is what Newton's first law is. A body is at rest, will be at rest. If a body is in a motion, it will be continuous motion until and unless an unbalanced force acts on it. That is Newton's first law. Okay. So this is all about the types of forces. Force is a very simple term, but we have discussed around 15 to 20 minutes with a practical demonstration to what is force. Okay. One more force I have for you. I will just show you. This is the basic concept of rocket propulsion or rocket launching. If you see this, I have filled the air and this balloon, and if I release this by keeping this on the table, you just see the direction of this balloon. It moved in upward direction. The reason behind is, if you see here, I will just draw that diagram here. If you see this rocket, the exhaust gases comes out and apply certain amount of force in downward direction, due to which this balloon or the rocket goes up. This is the exhaust gases, and this is the direction of force acting on the rocket, which is called upthrust. So this is also kind of contact force. As soon as the air molecules comes in contact with the surface, then only that will apply the force on the surface, due to the exhaust gases, the rocket will move up or the balloon will move up. So this is also a kind of contact force applied by the exhaust gases during rocket propulsion. Now the frictional force have a very important significance in our daily life. It is a kind of necessary evil. Friction is necessary also, and it is an evil also. Without friction you cannot write. Without friction you cannot walk. But if you see in machineries, if the friction happens, then the wear and tear of the machines happens. Friction takes place in your tires of the vehicle, which damages the tire also. But without friction, the tire will not move also. So friction is a kind of necessary evil. It depends on the surface. More rough the surface will be, more friction will be there. I have here two weights of equal block. One I have kept with the paper surface, and on the other I have put it cello tape. We just need to see which block will comes down first, or which block will move first, and we'll be able to discuss how the friction depends on the surface. More rough will be the surface, more friction will be there. This is the plastic ball. I am keeping it in the extreme left, and this is the surface with the paper. I am keeping it in this right direction. You just need to observe which block is moving first. And I have this different angles here. I can show you these different angles are here, or we can discuss it one by one also. We can discuss it one by one, there is no issue, or we can discuss it together also, there is no issue. We just need to observe which block will come first. I'm going to move it slowly. The plastic block has come first. So this is very much clear that the plastic and this surface is little smooth. That's why it came first as compared to this paper. Okay, so more smooth will be the surface, less will be the friction. More rough will be the surface, more will be the friction. We will have a detailed discussion on this friction. Maybe in the next class we will dedicate one complete lecture for friction only. Okay, so bye bye. See you in the next class. Hope you all are well and safe. Thank you.